So we have pure math vibes with the OG Emma. Emma, big up yourself. Right. If you're watching this on YouTube, pure math students, Emma real smart. She's just kind of tired right now. So like she operating at like not max capacity. So just put that into perspective. But Emma could do these questions in like 3 minutes at full capacity. Emma built different. All right, so Emma, part A, using the Moore's theorem, show that sine to the power 3 theta is equal to a quarter 3 sine theta minus sine 3 theta. Talk to me. How are we gonna start this off?
Um, well, you could start with the cos theta plus I sine theta minus cos theta minus I sine theta to get 2I sine n theta. Well,
So you want to start off with the full thing. So we have a complex number, and the complex number will be equal to z is equal to cos theta. Like this you want to start off at?
yeah,
Okay, no problem. And if we use the Moore's theorem, and you were to raise this complex number to the power n, what would that do to the angles?
you'll get cos n theta plus I sine n theta.
Awesome. So what do you want to do with this now? So you have for z is equal to cos theta plus I sine theta, and you have for z to the power n is equal to cos n theta plus I sine n theta.
Well, you want to get it in the form a sine
Correct.
first. So you'll have z to the n minus 1 over z to the n.
Say that one more time.
Well, z to the n minus 1 over z to the n.
You're saying z to the power n minus 1 all over n.
Mm-mm. No, power in like in the brackets, z to the n minus 1 over z to the power n.
Wait, I'm trying to wrap my head around what you're saying there.
Z minus 1 on z.
Oh, okay. Z to the power minus 1 on z. Yeah. So here, well, before we do that, let me just quickly find z to the power minus 1. So whatever we put the power to, we're going to multiply the angle by that. So if it's z to the power minus 1, then that's going to be cos minus theta plus I sine minus theta.
Mm-hmm.
Now, cos minus theta, that's just going to be cos theta because the way in which the cosine graph operates, the cosine graph is just a mirror image about the y-axis. So
My,
positive and negative values for theta give the same output. And then I sine minus theta, that's going to be minus I sine theta. And well, z to the power minus n would just be what?
cos of minus n theta. Wait, no. It would
Correct.
just be cos n theta minus I sine n theta.
Try just speed running that. Yeah, right? So we have z to the power n, z to the power minus n, and z to the power minus 1. Awesome. Now, we want to figure out sine to the power 3 theta. So what could I do with these? What could I do with this and z to the power minus 1 to get sine? I want to get sine. Should I minus them? Should I add them? What do you think?
You minus them.
Right, I should minus them. So z minus z to the power minus 1. Now, straighter, let me run through this carefully, right? So we are minusing them. So we're minusing this and this. So cos theta minus cos theta, that cancels off. And then we have I sine theta minus I sine theta. A minus by minus is a plus. So this is really plus I sine theta. So I sine theta plus I sine theta is 2I sine theta. So that is what z minus z to the power minus 1 is. And we're going to utilize this to figure out sine to the power 3 theta. So Emma, walk me through the rest.
You would have z minus 1 on z to the 3.
Mhm.
So
And that would be
mm,
equal to what?
expanded, or
Oh, the right-hand side. What would that be equal to on the right-hand side? If we look at this, we cube both sides.
you mean 8? Oh, wait, hold on. What's I cubed again? I think it's minus I.
Correct, because I squared will be minus 1 by I, minus I, yes.
So it's minus 8I sine theta.
Sine to the power 3 theta. Yeah? I'm gonna if you
Yeah.
right. So now we need to expand this using binomial theorem. So walk me through it.
C cubed. Well, if you want to do the NCR thing.
You know what? Since it's like just to the power 3, if you want, you can just do Pascal's triangle. But you know what? In the interest of time, we could just use that. So this would be 3 choose 0. That'll be 3 choose 0. And that would be what?
C to the power 3.
Right? That would be z to the power 3 minus 1 over z to the power 0. What would the next one be?
3C1. 3Z. Wait, sorry. Sorry. Z squared by minus 1 over Z.
Right?
And then plus 3C2. And you'll have Z by minus 1 on Z squared. And then plus minus 1 on Z cubed. Well, it'll be 3C3.
But we know that will be 1. Yeah. We're just running for looking here. That'll be z to the power 0 minus 1 over z to the power 3. Nice. And well, we know that z minus 1 over z to the power 3 was the minus 8 sine cube theta. Pen I here one time. So 3c0 is 1, and minus 1 over z to the power 0 is 1. So really, that's just z cube. Because 1 by z cube by 1 is just z cube. All right. And 3 choose 1, that is just 3. So you're going to end up with really a negative. So that's going to be negative 3 all over z multiplied by z squared. You got that, Ants?
Yeah.
All right. The next one is going to be 3 choose 2. That's 3, Ants.
Mm-hmm.
All right. So that'll be 3. Um, so that'll be 3, and it's minus 1 over z squared. So that'll be 1 over z squared. So that'll be 3 over z squared multiplied by z. And 3 choose 3 is just 1. So that'll just be negative, because it's minus 1 over z to the power 3. So that'll just be minus 1 over z cubed. You got that as well, right?
Yeah.
Okay, cool. Okay, so now we could group together this thing so that we can get any form z to the power n minus 1 over z to the power n. Agree?
Yeah.
And if it's in this form, that would produce 2i sine n theta,
Mm-hmm.
right? So that would be z to the power 3 minus 1 over z to the power 3.
Mm-hmm.
And then we, over here, just going to simplify this quickly. Right, and well, so if you work that out, that is going to give you, um, that'll be minus 3z plus 3 over z. So what will we have to factor out?
You factor out minus 3. Well, you just factor the minus.
Yeah, you have to factor out the minus. So if anybody is confused, you want to get it in this particular form. So you have to factorize accordingly. It's already in the form here. You don't have to do anything. But over here now, notice that there's a plus sign in the middle. So you'll factor out the negative. So minus 8I sine to the power 3 theta. And all right, so it's z to the power 3. So n would be what in this instance? What would n be over there?
3
Yeah. So that'll be 2I sine 3 theta.
theta.
And we factor out the negative 3. So that'll be z. Now to get back plus 3 over z, I'll have to put a minus here. And that'll be minus 1 over z. And well, what is z minus 1 over z?
2I sine n theta. Wait,
Nah, no n.
yeah? What did you have? I was wondering, what did they ask me?
So z minus 1 over z is what?
2I sine theta.
Yeah. And we want to prove 1 over 4 3 sine theta. Okay, no problem. So we should factor out. Okay, they want positive 3 sine theta. So we'll definitely have to factor out the negative. So negative 2i. Let me know if you catch that.
Mm-hmm.
So if you factor out negative 2i, what would I write inside?
Sine 3 theta
That'll be minus sine 3 theta.
minus sine 3 theta plus 3 sine theta.
Right. And we want to get 1 over 4. So what do you do next?
Divide by minus 8 row.
Not just minus 8.
8i.
Right. I feel like as soon as this thing done, you want to have the biggest sleep in your life. Like best sleep in your life. Like I could hear it in your voice. Like you just want like I know it's just like let's man finish this fast now. What's sleep boy? Hey.
And so
That's fine. That's fine.
I just do a thing just to get the answer and move on.
You do what thing?
I didn't even factor it out or anything. I just divide. I just divide by 8 and move on.
It's fine. Oh no. Yeah, you're supposed to divide by the I too.
Yeah, I divide by the 8i. I got the answer.
Okay, cool. I don't just like do all of this working, so I just don't want anybody to be lost now. So I have a feel like if I like jump the gun and only looking back at this, I might be confused. And that's the answer there. So Trita, if you're looking back at this, we quickly derived this identity here using the Moivre theorem. So again, quickly, z is equal to cos theta plus I sine theta. And this is in the trigonometric form. Using the Moivre theorem, if I raise the complex number to a power, it multiplies the angle. So using this, I would have also found z to the power minus 1. That just makes the angle negative. And I also found z to the power minus n. Now I want to find sine to the power 3 theta. So I'm asking myself, what would I need to do with z and z to the power minus 1 to end up with sine alone? Well, if you subtract them, you get 2i sine theta. Because the cos theta's cancel off, and this turns out positive I sine theta. So 2i sine theta. Next thing you want to do is you want to cube both sides because you want to prove sine to the power 3 theta. Now, for the left-hand side, you'll have to use the binomial theorem, which is what we did over here. And long story short, this is what we ended up with at the end. We had to factor out the negative 2i and divide by minus 8i to end up with a quarter. And that's it. Lovely. Let's tackle part B now. So, Emma, do we really want to go and find cos to the power 3 theta and all that?
No.
No, no, no. Why are we doing all of that? So let's recall the double angle identity for sine 2 theta. Remind me fast. Where's sine 2 theta equal to?
2 sin theta cos theta.
Right. 2 sine theta. And so, can you see a connection between this and this?
Mm-hmm.
Where's the connection?
Well, as you see, when you could divide by 2, so you'll have the sin theta and cos theta alone. And when you cube it, it would look the same as sin cube theta, cos cube theta.
Correct. So we could half. So if sine 2 theta is this, then half of sine 2 theta would just be equal to, would just be half of 2 sine theta cos theta, which is just sine theta cos theta. But we want to write sine cube theta cos cube theta in terms of the double angle identity. And now sine cube theta cos cube theta is just sine theta cosine theta all to the power 3. And so what we could do is we could just cube both sides. And if we cube both sides, we're going to end up with 1 over 8. Not with, we're going to end up with sine to the power 3. And Emma, are we going to raise 2 theta to the power 3 as well?
No.
No, because 2 theta is just the input for the input, right? That's like where you put an e into the trig function. That's just our input.
Yeah.
So we're not touching that. Emma, I need a power up, boy. It's all like you're on dead. All right. Okay, so we have 1 over 8 sine to the power 3 2 theta is equal to sine cube theta cos cube theta. No, I'm smelling something. I'm smelling something. Don't worry, I'm not smelling you. I'm not smelling you. I came up with an expression for sine to the power 3 theta. So it shouldn't be too hard to figure out what sine cube theta 2 theta is going to be. Oh, it shouldn't be too hard. So let me tackle that. Let me tackle that quickly. So Emma, I'm just gonna replace theta with what? So like this and this looking real familiar, like real familiar. Like
You replace theta with 2 theta.
correct. And so sine cube 2 theta, all we're gonna do wherever you see theta, remember, Emma, this come like composite functions. Remember in composite functions, you would put the inner function into the outer function, you like plug it in. So like over
Yeah.
here, we have this is theta is the input, right? But instead of theta, you're plugging in 2 theta. So wherever you see theta, you just gonna put 2 theta. So that'll be 3 sine 2 theta minus sine. Over here, we had 3 theta, but you're putting in 2 theta. So that is really 3, 2 theta. Now sine cube 2 theta is just going to give us a quarter. 3 sine 2 theta um minus sine 6 theta. You okay with that, right?
Yeah.
Right, we're cooking. Although I feel like we're out of gas, but we're still cooking. I don't know how we're cooking, but we're still cooking. So we know what sine cube 2 theta is, so I could just plug that in here. So we wanted to figure out what 1 over 8 sine cube 2 theta was. So that shouldn't be a problem. So 1 over 8 sine cube 2 theta would just be equal to 1 over 8 multiplied by 1 over 4. I don't know why I put in brackets, but you don't have to do that. 3 sine 2 theta minus sine 6 theta. And that's going to be 1 over 32. Hopefully, I could multiply correctly. I hope. Emma, you just find yourself using a calculator excessively in pure maths?
Mm-hmm.
Like more than in hard maths?
I think I used to use it. I used to use it way more when I was doing hard maths.
Dude,
The calculator is just more support for pure maths.
when I showed you like how to do the paper ones for pure maths, you could solve the 70 to 90% of the paper without Casio.
I, I had we for my paper one for mocks. For the differential equations questions, I was having the most problems. Well, I revised it that well, but I mean, you can't plug it into a calculator.
I sure it have like some. I would check. I don't know. I'm not guaranteeing that. But Casio calculator is crazy. The other day, I figure out how to find the LCM and GCF with the Casio calculator.
Okay.
Yeah. So let me continue. So we prove it. We just prove it. So Shweta and anybody that might be watching this, let me just run through this quickly. So they said hence show that anytime they use the word hence, chances are they want you to use what you did previously. Now, an alternative to doing this question, you could have found for cos to the power 3 theta. Now, to find for cos to the power 3 theta, you'd have repeated the same procedure, but you know what? Instead of saying z minus e to the power minus 1, you would say plus, and you would end up with 1 for cos instead. And then from there, we'd have to cube it and follow more or less the same working. But we decided to take a smarter approach. We saw that sine to the power 3 theta cos to the power 3 theta looks like sine theta cos theta to the power 3. Now, sine theta cos theta is just half the double angle identity for sine. All right, so a half sine 2 theta is just equal to sine theta cos theta. Then we cubed both sides and we got 1 over 8 sine cube 2 theta is equal to sine cube theta cos cube theta. Now, earlier, we found that sine cube theta was equal to this. So we're just going to plug in 2 theta instead. When you plug in 2 theta, you get 2 theta for theta. And instead of 3 theta, you get 6 theta. Bam. Then you just substitute. You know that sine cube 2 theta is this entire thing. So you plug that in and you get 1 over 32, 3 sine 2 theta minus sine 6 theta. Bam. Easy. Easy peasy. Lemon squeeze. Last question. All
So,
right. So this should take you back to Adma's days. So again, they're using that word hence.
so you bring them backwards here? No, already from the last hence, but do 1 over 32 by whatever. So you would replace that with sine cube theta, cos cube theta.
One second for me. Yeah. So we hate like it's really, really tough to integrate trig functions when it's raised to our power. So you always try to bring it in a form where it's like you're multiplying the angle by something using one of the trig identities. So we actually did that. So we was able to, yeah, so we was able to write sine cube theta cos cube theta as this over here. That's what we were able to do. So I'm going to just copy that and put it over here. So we actually want to integrate this, which is not hard. So Emma, since we factored out the 1 over 32, am I integrating? Or we could do that.
What?
Since we have 1 over 32 multiplied by the entire thing. 1 over
Oh,
32 is so
you could put it in front the integration sign.
right.
And then now you could integrate normally.
Oh God, I forget the d theta. Hey, wait, boy. And I'm posting this on YouTube. Nah, boy. Not like almost as bad as forgetting plus C.
Oh, that's a variable plus C in this question.
Because it's a definite integral. Thank God. Right. So 3 sine 2 theta. Now, if we integrate sine 2 theta by itself, what's that going to give you? Well, you're going to get minus. So that's going to be minus 3 cosine 2 theta. And you're gonna put the derivative of the function here. So if you differentiate 2 theta, that'll just be 2. So long story short, if you have to integrate, if you're gonna integrate sine f of x dx, that's just going to be minus cosine f of x all over the derivative of the function. Yeah. So I hope we're not confused. 3 sine 2 theta. Again, if you integrate sine 2 theta, it's going to turn to minus cos 2 theta. And if you differentiate 2 theta with respect to theta, it should be 2. All right, next one. That's going to be minus.
No, it'll be plus.
So that'll be minus cosine 6 theta all over 6. Badness. And let's put the upper limits, the lower limits. So that's going to be minus 3 over 2 cos 2 theta plus 1 over 6 cos 6 theta. This feels so archaic. I had to go and plug this in now. And cosine are 0, 0.
What?
Nah, cosine are 0 is 1. What I was saying, boy. Boy, like the cosine graph literally looks like this. When the angle is at 0 is 1. Hey, nah, boy, I feel shame, boy. Nah, that's crazy. I was trying to skip it now. Like when I have a sine function, right? And the lower limit is 0, you could just ignore it. That entire thing.
Yeah.
I was being wishful for a minute there. Damn, that's
Okay.
the wrong thing. Okay.
As soon as I see it, I plug it into my calculator to make sure.
He was like, just to make sure, to see if it'll get a 0 now. To see if it'll get a 0. But unfortunately, it didn't give you a 0. Cosine doesn't work like that. So that's gonna be, so anywhere I see theta, just gonna plug in the upper and lower, well, the upper limit first, then minus the lower limit. So that's gonna be 2 pi over 3
But
plus 1 over 6 cosine. So if you have 6 pi over 3, 3 into 6 is 2, so that'll just be 2 pi. I confused it, you understand that?
okay.
And we
Um,
know that cos 0 is what? Cos 0 is what?
one.
Right. So we're just gonna say minus 3 over 2, because this gonna be 1, and well, this gonna be 1. So it's really just minus 3 over 2 plus 1 over 6.
Yeah. I got 11 on 12 for the 8 pi on 3 part. Wait, so why you have 2 pi in the bracket? Isn't it 2 pi on 3? Oh wait, no, not fine. It's fine.
Yeah, so pi on 3. So 2 pi on 3, I think that's supposed to be minus a half. So I think it's minus a half. Well, 2 pi is 1. So that'll be minus 3 over 2 plus 1 over 6, which I think is minus 4 over 3. No, that's 11 over 12. I think it's supposed to get 11 over 12 for this.
I got 11 over 12 for the other one. I don't know what I did wrong.
Oh, no, this is supposed to be 11 over 12. We get 11 over
Oh
12.
yeah.
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 And well, the other one I think is supposed to get minus 4/3.
Listen, let me see the thing again. 3 and 2 minus 1 and 6. 4 and 3. So, I got 9 over 128.
Come on, just yeah. Say that again.
9 over 128.
Wait, you get 9 over 128 for what?
The answer.
Oh, okay, okay. I'm gonna take your word for it, huh? Taking your word for it. Yeah, because
This 1 over 32 by 11 over 12 plus 4 and 3.
so that'll be 11 over 12, and then that'll be minus 4/3, which is plus 4/3. And well, that would be 16 over 12. So that really be 27 over 12. And well, the numerator would have to be 27. And well, the denominator would have had to been 32 by 12. And 32 by 12, 32 by 6 is 1. Wait, 32 by 6. That would be 192. And 192 by 2 is 384. And you get 27 over 384,
I got 9 on 128, but I guess it just reduced.
as opposed to, because 3 into 27 is 9, and that will be 1, and then that will be 2,
Yeah.
and 8. Well, good, and that's it. Nice. Imagine a question like this come for your exam, where sin to the power 3 theta cos to the power 3 theta is equal to 1 over 32, 3 sin to theta minus 6 sin 6 theta. Yeah, imagine something like that come. If something like this come, you go tag me in the exam and be like at math vibes, something like that.
I just hear your voice
Yeah.
in my head.
But I know you're very eager to go and sleep. So let me not keep you back. You have a good night, Emma. Take care.
You just said bye.